Hello, my friend, and welcome to Origins. My name is Don Chapman. It's my privilege to be your host. You know, Origins is a forum where we take the evidence of science and we use it to validate the truth of creation. And today we have with us Dr. Steve Austin. Dr. Austin, today we're going to talk about Mount St. Helens, and the subtitle I love, The Explosive Evidence for Creation. Now, there's a real intertwining between your own life story and Mount St. Helens, isn't there?
I was a graduate of University of Washington. Mount St. Helens was my favorite volcano.
Yeah.
And then I came here to Penn State University and did a dissertation on a wild idea about how a coal bed might form underneath a floating log mat. And then Mount St. Helens exploded, made a living modern example of a floating log mat, and I needed to go back there and discover what it did.
So in many ways, Mount St. Helens validated your dissertation.
My PhD dissertation found a very comfortable confirmation at the volcano at Mount St. Helens.
Wow, that's really exciting. So you've been to Mount St. Helens a lot, is that fair to say?
And it's a favorite. Mount St. Helens and Grand Canyon are two of my favorite places on Earth.
In fact, you're probably one of the foremost authorities on what happened at Mount St. Helens and the after effects of that to the environment. Is that fair to say?
I love to talk to people about Mount St. Helens and love to go there.
Well, you've got your chance today. Tell us about Mount St. Helens and what you want us to learn.
Well, just to call attention to this 9-hour eruption on May 18th, 1980. It released 440 million tons of TNT blast energy. 33,000 Hiroshima-sized atomic bombs.
33,000 Hiroshima-sized atomic bombs.
And it was a colossal explosion. And atomic bomb a second, essentially. So that's the power output of this volcano. And the scripture, Psalm 46, verse 8, "Come, behold the works of the Lord, what desolations he has made in the earth." And I take that literally, right?
Yes, sir.
So I go out there to see those desolations. And of course, we remember what the mountain looked like before. It was a very beautiful mountain.
Pristine, beautiful.
Yeah, forest, lake, everything. And then it lost 1,300 feet of summit elevation on the morning of May 18.
Wow.
This gigantic landslide, half a cubic mile of summit slid away into the lake and into the river basin next to it. And then behind it, the big steam explosion. And it was just extraordinary. This is the before image, before the eruption. And you can see this area. I've got the next photograph from exactly the same position after the eruption. But I'll call your attention to this. You want to look at that. You want to look at that right here. And you might want to look at this ridge right here. Okay, now, here it is after. Watch those points carefully.
They're gone.
Yeah, look, the top of the mountain completely changed.
Wow.
And it lost 1,300 feet of summit elevation. It's hard to believe it's the same mountain.
Yeah.
Okay, it was incredible geologic change. It was Disneyland for catastrophic geologists like me to go see what the geologic change was there at the mountain. Here's a simulation of the first 50 seconds of the eruption. As the earthquake shook the mountain, 5.1 magnitude earthquake, the whole north slope began to slide in a gigantic debris avalanche. This debris avalanche, moving at freeway speed off the mountain, dispersed rock fragments, released the pressure inside the volcano. Super hot liquid water in the magma in the chamber flashed to steam. And a supersonic steam jet propelled itself over the debris avalanche deposit. So down there next to the lake, the steam blast actually got there first and knocked down and toasted the forest. That's the simulation of what we think happened during the first 50 seconds of the eruption. The southwest corner of Spirit Lake, right in here, is the site of up to 600 feet of deposits. Up to 600 feet of deposits have formed there since 1980. There's a new landslide debris dam for the lake. The lake is occupying a different position in space, higher than it was sky before the eruption. That's now sky. And this whole landscape something like 62 square kilometer area of debris avalanche deposit has sat there. Over the last 30 years, we've been able to study what's been going on there. It's Earth's newest landscape, and rapid deposition occurred there. Here you see one of these pyroclastic flows, a glowing avalanche of particles, a dense avalanche falling off of the mountain. These pyroclastic flows are amazing, and they call our attention to the swift process. When the pyroclastic flows stop, they freeze rapidly and they form these very interesting deposits. In cross-section, you can see what a pyroclastic flow deposit looks like. Right here is 25 feet in thickness, a pyroclastic flow. That pyroclastic flow is right there, 25 feet in thickness. That formed on June 12th, 1980, by a 3-hour eruption where glowing avalanche of particles came off the summit. And it deposited a layered or laminated deposit. It was very interesting. Here you see the 9-hour eruption on May 18. You see the June 12th deposit, and then you see the March 19th, 1982 mudflow deposit. Each layer at Mount St. Helens has a date. And that's amazing. And so as I started looking at the June 12th, 1980 3-hour eruption deposit from late in the evening on June 12th, I started seeing that lamination. Here's the top of it. See the layered appearance? I had thought that the catastrophe would homogenize the coarse and the fine. And this avalanche of particles actually separated the coarse and the fine into layers. And so that was shocking to me, because I thought that something moving so fast like that would homogenize the layers and mix them all together, not separate them out. And the closer you get to the June 12th deposit, the more layered it becomes. There's just a foot or so of the upper part. And even lamination right in here formed, believe it or not, in a hurricane. Okay, that is unbelievable. So the particle separation rapidly challenges my way of thinking about stratification elsewhere. You know, in the Grand Canyon, the Tepete sandstone is 350 feet thick. And that has, it's a sandstone and it has layering like you see at the pyroclastic flows at Mount St. Helens. And so I started thinking about the sedimentary evidence of rapid accumulation of sandstones in the Grand Canyon. We've been accustomed to thinking in terms of maybe 50 million years to deposit hundreds of feet of sandstone. Yet at Mount St. Helens, we've seen the actual process that can form the layerings and the stratification rapidly.
In one day?
Essentially in a day. 3 hours there, we saw 25 feet
25
of
feet
strata
in 3 hours.
that formed.
Yeah.
So these processes go on, and we need to understand them and their application to other strata layers, like in Grand Canyon. So I find myself believing that a global catastrophic flood can form sedimentary layers like in Grand Canyon on the basis of seeing the laboratory experiment that God gave us at Mount St. Helens. Okay, now there's a large amount of erosion that occurred, especially to the debris avalanche deposit after the eruption in 1980. And these erosion features formed rapidly. Like there were jetting steam from buried ice and water at depth underneath the hot volcanic ash. Within days, steam was jetting to the surface. There's the lake, Mount St. Helens Spirit Lake, covered with logs. And then it came back, and look at this. The steaming had stopped a month later, and we see around the big steam explosion pit this rill and gully topography. The rill and gully topography is amazing because that formed within 5 days by gravity collapsing the lip of the pit as this steam eruption was occurring. Yet it reminds me of the Badlands of South Dakota or some of the deserts of the southwestern United States.
And if this could form quickly, that did too.
Yeah. So I find myself saying, what is there that can't form rapidly? Like, for example, here's an ancient lava flow from probably about 500 years ago that was gouged out after the summer of 1980 by a mud flow that came through here. This is on the north flank of Mount St. Helens. Solid rock was gouged out by a mud flow. And today we see the small stream and the waterfall going through the canyon. So rapid canyon formation related to catastrophic process like mud flows. This is a deep canyon over 100 feet deep, eroded through solid rock, ancient lava flow, ancient volcanic landslide deposit, ancient volcanic ash layer. All that was gouged out after the summer of 1980. So erosion is prominent right in front of us, and hard rock erosion making extremely large cliffs and deep canyons. Okay, March 19th, 1982, there was, behind the lava dome at Mount St. Helens, back in there, a lot of snow, and that snow melted when the summit eruption occurred. It wasn't a big eruption, but it melted the snow rather rapidly and created what? A big mud flow came down. And a lot of water from the 15 feet or so of melted snow in there all of a sudden came down, and it mixed with volcanic ash and formed the mud flows. Most of the mud flow went down the North Fork of the Toutle River this way. Also, some of the mud went into Spirit Lake. And that mud flow of March 19, 1982 was big enough to overtop the debris avalanche deposit and cut a canyon through it. And so I've been very interested in studying the area right in here, this area where the big breach occurred, where mud spilled into a pit, overtopped a dam, and then drained through a spillway, back cut a canyon, what I call a Little Grand Canyon. Here you can see the area where the mud flow came. The mud flow came down out of the crater, right through this area right here, ponded right in this area, then it overtopped, came down this spillway, and went down to the ocean. This giant mud flow had enough power to overtop that barrier, and as it overtopped the barrier, it cut back through and made, right in that little area there, a Little Grand Canyon. So saw this canyon as I ventured in that area, saw this canyon, and it was amazing. Okay, I can see many of the same features as the real Grand Canyon. The cup-shaped side canyons right here, the gully-headed side canyons that extend up into it. And then notice we have a flat plain north and south, okay, like the real Grand Canyon, and then the breach has a kind of a turning path as it goes through. And so the snaky path reminds me of Grand Canyon terrain. Sure. And so in 1983, in August, as I overlooked this, I thought, oh, this is a Little Grand Canyon sitting here. And started calling it Little Grand Canyon. Now it's in the peer-reviewed geologic literature, Little Grand Canyon. And so the Grand Canyon is something to think about as you stand here and ponder that terrain. Look at the freestanding cliffs and the small stream. The right canyon over here, I'll show you in the next image. Here it is, 140-foot cliff, small stream flowing through that canyon. Do you think that small stream eroded that big wide canyon one sand grain at a time?
I don't think so.
Okay, it might appear that way, but we have the eyewitness reports. And this was formed by catastrophic drainage over a period of months as drainage occurred through there, and it created this canyon. There is a man right there for scale on top of that cliff, okay, and there's a small stream, okay, and you think about that, is that millions of years of erosion or a rapid event? And of course, we all need to appreciate what rapid erosion can do at Mount St. Helens. And it reminds me of the Grand Canyon. The evidence of a lake was off to the east of Grand Canyon. That lake may have overtopped the dam in north central Arizona here, the Kaibab Upwarp, and as the lake drained through, it could breach a spillway, just like at Mount St. Helens. Mount St. Helens is a breach dam formed by mud. Grand Canyon could be a breach dam formed by catastrophic drainage of a huge lake.
It just seems to me that if you look at catastrophe as the reason for one, which we know because, I mean, it's verifiable, then you have to think catastrophe when you look at the Grand Canyon. You absolutely have to, yeah.
And almost all geologists now are of the opinion that the Colorado River did not cut Grand Canyon. And we're asking, what did really make Grand Canyon now? And we're going to some way out thinking, like thinking about Mount St. Helens, catastrophic drainage of mud breaking the dam. Well,
Sure.
I've been involved with looking at the logs and log deposits of Spirit Lake. And I was out at Spirit Lake, sitting down there next to the lake eating my lunch, and I saw these 3 sticks that floated in. Notice the top of the sticks is floating out of the water. And these guys are sitting there standing upright. And it reminded me of the logs. Could the logs also float upright in the lake? And a million logs were floating in the lake. Could they also go into upright position? They could sink to the bottom and become upright standing logs, I thought to myself. Then they could get buried with the root ends at different levels. I had a hypothesis by looking at those floating sticks that gave me an idea that I needed to check out about the bottom of Spirit Lake. Could the logs float in vertical position, sink to the bottom, and get buried in standing position at the bottom of the lake? If they could, that would be a radical thinking of the ordinary way of how wood gets petrified in the earth. Because how do we think of upright standing logs in strata layers? We think, oh, there was a soil and a forest that grew there and was later buried. And so this idea was a very outrageous idea, contrary to the idea about how forests might be buried. These are embedded or replanted forests, okay, in the bottom of the lake. Take a look at the log mat on Spirit Lake. Millions of logs were floating on Spirit Lake the day after the eruption, and then these vertical logs start appearing, and inclined logs start getting deposited. And if you look at the log mat itself, there's evidence of upright floaters in the log mat and off to the edge. These upright logs can float with the root ends mostly weighting them down and get buried. So I was able to get out into Spirit Lake with a boat and with a sonar. And here's a sonar recorder. The sonar recorder is a device that reads the profile of the lake. There's the automobile batteries that power the sonar recorder. We made a profile and did a survey of the bottom of the lake. You see this paper record that's given off by the sonar recorder, and we're looking out diagonally over the bottom of the lake, and we can see several feet of water, probably 50 feet of water or so, below the towfish, and we're looking at the bottom of the lake, and then we're looking out diagonally 50 yards or so over the bottom, and there's the first reflection from the bottom. But notice, I see a sonar reflector right there, inclined, and there's an inclined sonar shadow. There's a sonar reflector and a big sonar shadow behind it. And then I noticed, look at this, immense sonar reflector right there, and then a sonar shadow behind it. Even seems to have outflaring root mass. It looks like a log just buried there and replanted. So on the basis of the sonar records, I had to go diving in Spirit Lake. And I'm a certified research diver, and so I go diving in the lake. And that was difficult diving situations. Here you see the steaming lava dome. There I am. There's my diving buddy, and we're getting ready to look at the bottom of that upright deposited log in the lake. Underneath the log mat, you can see the logs floating there. And upright floaters amongst the log mats, standing upright as the prone floating logs are there around us. On the bottom of the lake, we saw the upright embedded logs on the bottom of the lake. That verifies that the logs are falling out and getting buried in the bottom of the lake. The logs fell out with their root ends buried at different strata layer levels in the lake, having the appearance of being multiple forests. And there I am, there's my diving buddy. Notice no bark on the trees.
Yeah.
So the bark has been peeled off and it's on the bottom of the lake in thick deposits. And if the bottom of the lake was buried with all that tree bark sitting there, it would make a coal bed, very much like the coal that we see in the geologic record.
Tremendous insight to perhaps how our coal was made. Dr. Austin, we have to take a break, and we want to come back and wrap this up and learn the lessons God has for us. So if you'll join me down here, and if you'll come back, we'll be back with you in a moment to bring the conclusions to the explosive lessons God has for us at Mount St. Helens.
Today's guest on Origins, Dr. Steve Austin, is a field research geologist with his PhD in sedimentary geology. He is senior research scientist with the Institute for Creation Research. He has been involved in geologic exploration for 40 years on 6 of the 7 continents of the world. Steve has also done extensive field research at the Grand Canyon and Mount St. Helens. He is the author of several books, videos, and more than 30 technical geology papers. One of his books, Footprints in the Ash, deals with the 1980 eruption of Mount St. Helens. Dr. Austin can be reached at Institute for Creation Research, 1806 Royal Lane, Dallas, Texas, 75229.
We're back with Dr. Steve Austin. Dr. Austin, you've been studying Mount St. Helens for nearly 30 years now. What are the takeaways? What did you learn from there?
Mount St. Helens is a living laboratory, isn't it, for study of volcanoes. And as we look at the volcano, I think we ask, is the humanist, the person who believes he's the master of his own destiny and control of everything, the humanist is humbled because there is power not under man's control. Somebody else is in control. And so we see colossal power and we think about the Creator's hand and about the sovereign power of God. As I think about the volcano, I also think about like Harry Truman, not the president, man of the same name who lived 80 years around the volcano. There at the volcano, he died. He failed to heed the warning. He lived at the south shore of Spirit Lake, directly north of the volcano. And his lodge and he were buried under about 200 feet of landslide debris. The government told him to leave, but he failed to heed the warning. And that reminds us of men, doesn't it?
Yeah.
We fail to learn the lesson. God's law is written on our heart, and we choose not to respond to him.
Old Harry said, it's always been this way for 80 years, it'll always be this way, and suddenly everything changed.
Yeah, his whole life was snuffed out, and he's an example of what? Obstinate 21st century man today.
I'm afraid that's true.
And so Harry teaches a lesson. And of course the volcano teaches me a lesson. You know, before the eruption, if you had come to me and said the volcano's going to explode and cause up to 600 feet of deposits to form, I would have said, nah, probably not. And if you would have talked about layered and laminated deposits forming in a hurricane, I would have thought that that was on the margin of sanity. About the only thing I might have agreed with you before the eruption was the idea that peat could be deposited underneath floating log mats. On the basis of some PhD research I was doing at Penn State University, I was thinking about coal beds forming from logs rubbing against one another, bark falling off on the bottom of the lake.
And you were about the only one thinking that. So
Yeah.
it verified that, and all of these other things are great lessons for all of us to learn.
I learned that God specializes in doing things that I think are impossible.
Wow.
And right there at the volcano, all kinds of possibilities were accomplished. It's a challenge to faith. And Mount St. Helens is the geologic vent of the 20th century. Now that we're in the 21st century, looking back on that time, that was the geologic learning experience of the 20th century.
We're very grateful to have you here with us, sharing your life lessons as well as your scientific knowledge. And I hope people will listen with their heart, not just with their ears. My friends, we have a big God who's at work in big ways, and he's going to work his plan. You know, once he destroyed the earth and reshaped it with water, the next time it's fire. I think we saw a hint of that at Mount St. Helens. We would be wise to learn the lessons of Mount St. Helens, not just the scientific lessons, the spiritual ones as well. You know, my friends, it's God's view that he created you. That should be your worldview too. So humbly I say, I hope you'll join us again here soon on Origins, and I hope you'll listen to God's voice until then. God bless you, my friend. It's good being with you.
Thank you for watching this edition of Origins. If you'd like a copy of the PowerPoint information presented today, you can download a PDF file of program number 1004 from our website at www.originstv.org. Or for a DVD of this series, send a $12 donation to cover shipping and handling and write to Origins, program number 1004, Cornerstone Television, Wall, Pennsylvania 15148.
Origins is made possible by the faithful prayers and the financial support of you, our Cornerstone Television family.